Welcome back. We're going to talk about surface area of prisms. So prisms are just shapes that have the same cross section throughout. So this has a pentagon on the top, there's a pentagon on the bottom, and it would have the same shape whether if I sliced it in half, it would still be a pentagon. Anywhere throughout the whole length of the shape, it has the same cross section. So that's what a prism is. So here's a triangular prism. Has a triangle, and the triangle, anywhere I cut it, you would see a triangle. This one is also a triangular prism, so same shape throughout. Rectangles are kind of special because they have the same cross section throughout, so this one has a rectangular cross section, but you could also think of it as a prism in this direction, so like the square being the same cross section throughout this thin length. So it has, actually it's a prism in three different directions, right? It's same cross section throughout this way, same cross section throughout this way, and same cross section throughout that direction as well. Cylinders, which are just circular prisms, that's just a new word, cylinder. You probably heard it before, but it has a circle in the same cross section throughout. So we're going to be finding the surface area of these first. Surface area is just, again, area is how many squares fit onto a shape. So let's start out with the rectangular prism. And when we draw these out, a good way to think about it is to make these into nets. And whether you're doing clothing design or laying out shapes for air conditioning ducts and things like that with sheet metal, to think about how much area you need. This is how you would do it, is break it out into a net and then break it down into smaller pieces and then figure out exactly how much area you need. So this one, I'm just going to trace it out to get a picture of the net, and it's kind of like wrapping a birthday present. You could think of it that way. So that side, that side, that side, and that side. So I covered all four of the sides. Let me get this on the screen there. Okay, so that was, I just went this way. And then I also need to get the two sides that I didn't get right because I rolled it that way. I didn't do these two outsides. So if I roll it this way, this is just rough. Okay, so I have a basic net there, and I want to just find the area of each of these faces. How many squares go in each face? So I'm going to measure it in centimeters. So this is 6 centimeters and 6 centimeters, and this length is about 3 centimeters. And then this would also be 6 centimeters, right? All of these lengths would be 6 centimeters. And this length over here would also be 3 centimeters. And that means this would be 3 centimeters. And this would be 3 centimeters. And this would also be 6, because remember that this side is the same as this side, right? So this is 6 centimeters. Okay. So the area of these shapes, I could just add them all up. Okay. So 6 centimeters times 6 centimeters would be 36 square centimeters. 6 times 6. So centimeters squared. And then this would be 6 times 3. So it would be 18 centimeters squared. And this would be 36. And this would be 18. And 18. And 18. Right, because this would also have to be 3 and 3. So my total surface area, I could add them all up, right? 18 plus 18 is 36. 18 plus 18 is 36. So I have 36, 36, 36, and 30. So there's 4 36s. So that'd be 36 times 4, which 6 times 4 is 24, and 3 times 4 is 12, plus 2 more is 14. So it'd be 144 square centimeters for the surface area of this prism. Okay, so let's try to think a little bit about the other shapes. I would think of it the same way. I could roll it out, and then I have each other side. So I'll just draw a little smaller here. So for a triangular prism, you'd have 3 sides, and then the bases on either side. So I'd find the area of each of these rectangles and add on the area of these 2 triangles. With a pentagonal prism, you'd have how many sides? Right? 1, 2, 3, 4, 5. Right? 5 of them. 1, 2, 3, 4, 5, and I have a pentagon base on either side. And by the way, this pentagon can go anywhere, and it would still make a net. So if you want to build your own pentagonal prism, you could do that, and it doesn't really matter where this ends up. And you just drop tabs on the end, and then you can glue it together. So what about a skinnier triangle prism? Just have a little bit longer, right? And with a smaller triangle on the ends, right? So just think about it that way. You roll it out, and then you have the 2 other sides. So you would find the area of each of these rectangles, and then the area of the 2 bases. So what about the cylinder? Think about that. What would this look like? We don't have any sides to roll out, but it would work the same. You could, think of the soup label that's going around the soup can, and if you peel that off, you would have a rectangle, wouldn't you? So there's some sort of rectangle. What is the length of the rectangle? And we know the height, right? The height is just the height of the cylinder. So that's the height of the cylinder. But the length actually, it matches up exactly with the length going around the circle, right? What is the length around the circle? Well, that distance we call the circumference. With these other shapes, you can think of it as it's the perimeter, right? The distance around this big rectangle is the same as the perimeter of that shape, isn't it? If I laid that out, it would be the same length, right? And so the same thing happens with the circle. If we lay it out, that distance is called the circumference. And we would have both sides there. So how many square centimeters, inches, whatever, would go into this shape? Well, we just multiply length times height, or length times width, or base times height. And the circumference of a circle is 2 pi r. And the area of each of the top and the bottom would be pi r squared and pi r squared. So you can derive a formula for the area of a cylinder using this idea. So let's just add them all up. So we have the area of each of the bases. There's 2 of them. So 2 pi r squared, right? So that's the 2 bases. Plus, we have the area of this rectangle, so 2 pi r times h. And people like to mess around with things and factor things out and rearrange everything. But that's the basic idea, is you are just finding those areas and adding them all up. And that's basically how it works. Just for fun, if I wanted to rearrange this and factor things, I could say this is 2 pi r, and what's left over, I have 1 r left over, plus I could factor 2 pi r from that, and what's left over in h. So sometimes you see it like this. It's the exact same thing. People just try to mix things up to confuse you. So don't worry about it. You know how to do it. You build the net and find out exactly what the surface area of these prisms and cylinders are.